Hello friends, welcome to Risingpearl.com. Today we are talking about Trigonometry Series 3, Trigonometry. This is webisode number 20 and this is the part 2 for trigonometric identities. So friends, let's look into it. Now as we discussed in the last video, which was our webisode number 19, that identity, by identity we mean any equation when that equation is always true for all values of the variable, then that equation becomes an identity. In other words, so now in the context of trigonometric identities, so if we have a right triangle, in this case we have a triangle ABC, angle B is 90 degrees. So we have a right triangle. So if we write any equation involving trigonometric ratios in triangle ABC, then if that equation involving the trigonometric ratios of one angle, if that equation is true for all values of that angle, then that equation becomes an identity. And we saw in the last webisode, sine square a plus cos square a equals to 1. In other words, that was the first identity that we saw, which is sine square a, where a is any angle, plus cos square a, again a is the same angle, is equal to 1. So no matter what values you take for a, this equation always is true for all values of a. So now we are going to take a look at two more identities specifically. So we have a right triangle ABC, angle B 90 degrees. So this is our hypotenuse. We are going to again start with Pythagoras theorem, which says AC square is equal to BC square plus AB square, which is basically hypotenuse square is equal to sum of squares of the other two sides. Now what we are going to do is we are going to divide both sides of this equation by AB. So we are going to divide AB by AB square. AB square, AB square, AB square. So if you do that, what you will see is, so this can be written as, actually let's move this on the other side and get this on this side. So we will have, or we will get BC by AB whole square. This is BC by AB whole square plus AB square by AB square. This cancels out. This will be 1 equal to, this can be written as AC by AB whole square. Now BC by AB for angle A, this is the opposite side. So BC by AB, and this is the adjacent side. So BC by AB, this ratio is really tan A, right? So this will basically become tan A whole square plus 1 equal to, now this is AC by AB. Now AB by AC will be, let's write it here, cos A. Cos A will be AB by AC. AB by AC. So AC by AB will be sec A. So this is sec A whole square. Or this will be tan square A plus 1 equal to sec square A. In other words, friends, this is our second identity, that is for any right triangle. So if you have any angle, if you take any angle in a right triangle, 1 plus tan square A is equal to sec square A. And this will be always true for all values of A. So this is our second identity. There is one more identity before we wrap up this presentation. So here again we take the same triangle. Now we are going to again start with the same premise. We will start with the Pythagoras theorem again. So what we have is, so BC square, Pythagoras theorem again, so BC square plus AB square is equal to AC square by Pythagoras theorem. Or this time we are going to divide both sides by BC square by, so we have BC square plus AB square, right? So this time we are going to divide both sides by BC square. BC square, BC square. So what we'll get here is, so this will cancel out, this is 1 plus, so this will be AB divided by BC whole square equal to, this one will be AC divided by BC whole square. Now if you look at this triangle, if you think about this angle, right? So angle A, this is our opposite side and this is our adjacent side. So AB by BC, which is AB by BC, is really cot A. Remember that tan A is opposite side by adjacent side, which is BC by AB. So cot A will be reciprocal of this. So AB by BC will be cot A. So this will be 1 plus cot A whole square is cot square A equal to AC by BC. So this is BC, this side is BC. So AC by BC is cosec square. So this will be cosec square A. So friends, this is our third identity. So this is our third identity. So in other words, we took a look at Pythagoras theorem in a right triangle, right? And the Pythagoras theorem initially stated that AB square plus BC square is equal to AC square, right? So we have three sides involved in a triangle. So first we divided both sides of the equation by the hypotenuse. That gave us the sine square A plus cos square A equal to 1, which we saw in the last webisode. Earlier in this particular webisode, we divided both the sides of the equation, the Pythagoras theorem, we divided both sides of Pythagoras theorem by the adjacent side AB square. That gave us 1 plus tan square A equal to sec square A. And finally, just now what we did was we divided both sides of the Pythagoras theorem by BC square, and that gave us 1 plus cot square A equal to cosec square A. So these are the three identities. So sine square A plus cos square A equal to 1, 1 plus tan square A equal to sec square A, 1 plus cot square A equal to cosec square A. It's important, friends, to also remember, I think we have not highlighted this earlier as much, that because these are identities, they are true for all values of A. A can have any value. Keep in mind that A, these are trigonometric ratios, and trigonometric ratios are always talked about in context of a right triangle. So in a right triangle, you have one angle 90 degree and the other angles are less than 90 degrees. In other words, these are true for any angle inside a right triangle. right? All of these cases, all these identities, we have listed 3 identities here, right? This is identity number 1, identity number 2, identity number 3. All of the 3 identities are true for all values of A, where A is an angle inside a right triangle. That means it must be greater than 0 degrees, because angle cannot be equal to 0 degrees, and this can be equal to or less than 90 degrees, because these are angles in a right triangle. The maximum value of this A or any angle can be up to 90 degrees or less, but more than 0 degrees, between 0 and or equal to 90 degrees. So for any of those values of A, each of these 3 equations will be always true, and so we call them identity. In the next webisode, we are going to take a look at some of the applications on what kind of questions you may get for that involve identities, trigonometric identities.